All right. Very good morning, everybody. Welcome to Home Institute. I am Surendra Reddy. I teach electrical machines at Home Institute. So, as you know, the title of the live session itself, I'll be discussing the previous 5 years of HPCL examination questions from electrical machines subject. I hope my audio was clear. Please let me know in the chat box if you are facing any issues related to audio or video. I think from my end, everything looks clear. The previous 5 years of HPCL examination questions from electrical machines subject. I hope my all right. So everything was clear. You know that HPCL is recruiting engineering graduates every year through their own examination. From past 5 years, from 2021 onwards, every year they are recruiting the engineers. So it is one of the standard exam, just like PSUs. You can trust on HPCL. Every year they will recruit engineers through a common entrance examination. Okay, so as you know, electrical machines is one of the core subject which carries major weightage, and you can see on an average we are expecting around 13 questions per year. Okay, so from past 5 years I found 65 questions. Okay, that means on an average 13 questions per year. So before proceeding to the session, what I observed from all these questions, is the questions are of basic standards only. Just they are asking the basic questions, but they are covering wide area. Okay, not leaving any single topic. Almost all topics were covered among the 65 questions. You cannot predict this area has more weightage or this machine has more weightage like that. So every machine has its equal weightage and almost every topic is being covered. But there are no difficult questions. All the questions are of basic standard questions. Okay, that means those who have basics properly, they can easily answer these questions. Okay, so without wasting our time, as your examination is very near, just 2 days ahead, I think this particular session will help you to revise everything that what you have studied. Okay, all right, so let's go to the first question. In DC motor, the difference between armature torque and shaft torque is called as dash, and it is due to dash. See, they are asking about armature torque. Armature torque is nothing but electromagnetic torque. This shaft torque is nothing but the mechanical load torque. Understand? And the question is about motor. And this particular question is not only applicable to DC motor, it is to any motor. You know that what is the duty of an electrical motor? Okay, if I wanted to call a particular machine as a motor, can I say it will convert electrical power to mechanical power? Yes. We will give electrical power as input and it will convert it to mechanical power. Therefore, electrical power is the source power. And this source power will create a torque known as electromagnetic torque. And this mechanical power is nothing but the load power or output power. This will create a torque known as load torque. Now what happens in electrical machines is always this source torque will support the rotation of the machine, and this load torque will always oppose the rotation of the machine. That means what is a supporting torque in case of electrical motor? Electromagnetic torque is the supporting torque, the torque which will allow the machine to rotate. And this load torque is nothing but opposition torque. It will always try to oppose the movement of the machine. Therefore, what is happening here? Yes. Now see, if you take a motor, who is the supporting torque for the rotation of the motor? Yes, the electromagnetic torque is the supporting torque. And who was the opposition torque? As I said, the load torque, or you can also call it as shaft torque, any word. Apart from load torque, there is one universal torque which always opposes the rotation of the machine, that is nothing but friction, or the torque which we are losing in the form of losses actually. Okay, so the friction, we know that any object which is moving in our universe will always be having a frictional opposition, right? Now what happens at a steady state condition, this supporting torque and these opposition torques balance each other. Okay, so I can write at a steady state condition, supporting electromagnetic torque will balance the opposition, load torque plus friction torque. Not only friction torque, wind opposition, all kind of rotational losses are included here. Now you take this load torque to the left side. So electromagnetic torque minus load torque is nothing but the friction torque. Therefore, the difference between electromagnetic torque, nothing but armature torque, and load torque, nothing but shaft torque, the difference is nothing but the friction. It is indirectly indicating the rotational losses of the machine. That means that is a torque we are losing or the torque we are gaining, that is the torque we are losing. So therefore, the difference between electromagnetic torque and load torque is nothing but the torque we are losing. And what is the reason for that lost torque? The main reason is rotational loss. Rotational loss. Rotational losses are basically, friction loss, windage loss. Iron loss is also known as rotational loss in DC machine. In DC machine, iron loss is also known as rotational loss only. Okay. So option B is the correct. See, the last one is wrong. This is also given as a lost torque. Up to this point is correct. Yes, the difference between the two torques is a loss only. But the loss is not copper loss, it is rotational loss. Copper loss is wrong. Copper loss is an electrical loss. Okay, but friction, these are rotational losses. Okay, so the answer for the first question is yes, option B. All right. Yeah. So let's move to the second question. A 200 kVA single phase transformer with a voltage ratio of 6600 by 660 volt has following winding resistances. Okay, see, primary resistance was given, secondary resistance was also given. Find the total resistance referred to high voltage side. We need to find out the total resistance referred to high voltage side. Can I say, according to the voltage ratio, high voltage side is nothing but primary side? So therefore, we are asked to find out what is the overall resistance referred to primary. That is, R01 is required. Okay, this is total resistance referred to primary. Total resistance referred to primary. Okay, yes. So you know that in a transformer, if this is the primary resistance R1 and here we have secondary resistance R2. Now our goal is to find out total resistance referred to primary. How do we find that? By transferring secondary resistance to primary side. We all know that when a secondary resistance is transferred to primary side, its value will become R2 dash. Okay, assume the turns ratio is N1 is to N2. Now tell me, I hope most of you know that, right? If a secondary resistance is transferred to primary side, what happens to its resistance value? So R2 dash will be equal to N1 by N2 whole square times of R2 ohm. Remember, okay? See, we are moving to primary side, so it is primary by secondary whole square. And according to the given voltage ratio, what is N1 is to N2? If I write N1 is to N2, is it not 10 is to 1? Okay, so therefore it is 10 by 1 whole square times of what is the secondary resistance R2? 0.015. 0.015. So it is 100 times, so 1.5. This is a secondary resistance referred to primary side. Now what is the total resistance R01? Therefore total resistance R01 will be, primary is already having R1. Now from the secondary side R2 dash is coming, so the overall value will be R1 plus R2 dash. So what is R1 value? 1.75. 1.75 plus 1.5. Is it not 3.25 ohm? Yes. So the total resistance referred to primary will be equal to 3.25 ohm. Okay. So 3.25 ohm means option A is the correct answer, right? Okay. Simple questions, okay? Basics only. Next, see, these are questions given in 2021 examination, HPCL Electrical Engineering 2021 examination. Okay, now let's move to the next question. With reference to wave windings used for DC generator, state whether the following statements are true or false. What is the first statement? Wave winding is used for high current and low voltage machines. Okay, with this first statement is completed. Second statement, the efficiency of wave winding is higher as compared to lap winding. Efficiency of wave winding is higher as compared to lap winding. See, the question is about wave winding, guys. Just a moment. Yes, the question is about wave winding. We all know that wave winding means number of parallel paths are equal to 2. If you look at lap winding, number of parallel paths are equal to number of poles. Okay, so for example, if the machine is having 4 poles, in a lap connection you will have 4 parallel paths, but in wave one connection will have 2 parallel paths only. Because the number of parallel paths are less, okay, so more voltage will be generated, right? More voltage and less current. More voltage and less current. Whereas lap connection will have more number of parallel paths, so it will generate less voltage and more current. Just a moment, guys. Just a moment. All right. Sorry, I got an important call. So anyway, so what is our discussion? Wave winding will have less number of parallel paths. Less parallel paths means more coils will be available in each parallel path. Okay. If more coils are available in each parallel path, what happens? More voltage can be generated. For example, I have 8 coils. If I connect 8 coils in 2 parallel paths, if every coil voltage was V, what is the total voltage? 4V. For example, if I connect these 8 coils in 4 parallel paths, what will happen? Each parallel path will have only 2 coils. Alright. Then what is the total output voltage will be equal to 2V only. So therefore, lap connection will produce less voltage, that's why more current. Wave winding will produce more voltage, that's why less current. That means, according to the given statement, wave winding is used for high current and low voltage. This is a wrong statement. Okay, wave winding is used for more voltage, that is high voltage and low current. Okay, not high current and low voltage. So first statement was false. When I say first statement was false, A and C are out of our options. The answer should be either B or D. Now coming to the point, second statement, they said the efficiency of wave winding is higher compared to lap winding. Yes, this is a correct statement. Why wave winding efficiency is more than lap winding? Because wave winding construction will have less chances for circulating currents within the parallel paths. Okay, you see this situation. Okay, you know that ideally what is our observation? Every parallel path will have same voltage, right? First parallel path will have 4V, second parallel path will also have 4V. Okay, therefore there is no internal circulating current. But practically what happens is producing 100% same voltage in every parallel path is not possible. I said practically, okay, because of various reasons. So therefore, when parallel paths are not having a similar voltage, internal circulating currents will flow. These internal circulating currents will create additional copper losses that will reduce the efficiency of the machine. But what my point is that in a wave winding, as the number of parallel paths are less, the chances for circulating current is very, very less. Okay, low chances for internal circulating currents. Internal circulating currents. Okay, whereas lap winding is having more parallel paths, therefore there are more chances for internal circulating currents. Because of these internal circulating currents, additional copper losses will be produced. Those additional copper losses will create extra heat, and that will reduce the efficiency of the machine. But in wave connection, there are very less chances for internal circulating current. Obviously, losses will reduce and efficiency will improve. Therefore, first statement is wrong, second statement is correct. That means last option is the correct answer. Okay. These kind of questions you can answer only if you have complete understanding over the theory part of the subject. Okay. Conceptual understanding is very important. All right. Let's move to the next question. For a synchronous generator supplying a balanced three-phase load, the armature reaction flux is dash in magnitude and rotates at dash speed. Okay, they are asking about a synchronous generator. In a synchronous generator, we know that two types of fields will be there. One is field flux, another one is armature flux, and both will rotate at synchronous speed. Okay, therefore, second statement is very easy to answer. Okay, synchronous speed. Synchronous. Subsynchronous is wrong. Subsynchronous is wrong. Super synchronous is also wrong. So straight away, three options are eliminated. Even though you don't know the answer for the first half, you can still answer A is going to be the correct. But let's understand what is the type of the load they are feeding. Balanced three-phase load. The moment I say balanced three-phase load, current will be a constant value most of the times. I can't say every time the current will be constant. Of course, whenever load changes, the current may change, but the word itself is balanced three-phase load. Therefore, every phase will carry equal amount of current. When I say the current carried by the windings is constant, the amount of flux created by that winding will also be constant, because flux is after all proportional to magnitude of the current. So therefore, because of the balanced load, I can understand the magnitude of the flux is going to be constant in magnitude, but rotating at how much speed? Synchronous speed. Okay, so option A is correct. Remember, whether it is a synchronous machine or induction machine, the fields will always rotate at synchronous speed only, both stator field and rotor field, and their relative speed is always equal to 0. Okay. So option A is the correct answer. All right, let's move to the next question. You please try to give me the replies in the chat box. Try to participate in the discussion. Yes. Okay. So let's move to the next question. Question number 5. A three-phase 4-pole induction motor is supplied from a 50 Hz source. Find the rotor frequency when the rotor runs at 600 RPM. See, we are asked to find out rotor frequency of the machine. And we all know that rotor frequency is nothing but slip times of supply frequency. So I have to find out the value of a slip first. Ns minus Nr by Ns. So what is the synchronous speed? 4-pole 50 Hz. That means, can I say 1500 RPM? Yes. 1500 RPM, that is 120 F by P, minus rotor speed is 600 RPM by 1500. So the answer is 900 by 1500. This is 3 by 5. This is the slip value. The moment you know the slip value, you can easily find out rotor frequency. That is slip times of supply frequency. So 3 by 5 into 50 Hz. Therefore, the rotor frequency was 30 Hz. Easy question. Okay. Right. This is the basic thing you will practice at induction machines level subject. Okay. How to find rotor frequency. And the question is easy because the machine is a motor. Okay. Motor means slip formula Ns minus Nr by Ns. Okay. For example, if the machine is in the braking mode, slip formula will change, ns plus nr by ns. Okay. All right. So the answer for this question is 30 hertz. Easy question, right? Yes, 30 hertz is correct. Okay. So let's move to the next problem. A single phase transformer has 200 primary and 700 secondary turns. If the primary voltage is 100 volt, find the secondary voltage. See, primary turns were 200, that is N1. Secondary turns are 700, that is N2. So the turns ratio N1 is to N2 is 2 is to 7. Correct? Primary voltage was given, that is V1. Find the secondary voltage, that is V2. We all know that in ideal transformer, V1 by V2 is equal to N1 by N2. From this, secondary voltage V2 will be equal to N2 by N1 times of V1. It's like a cakewalk for those students who have prepared well for AE exams or gate level exams. These kind of questions are nothing, right? So what is N2 by N1? It is 7 by 2 into what is the supply voltage? 100. It will be 350 volt. Okay. So the last option is correct. Easy question, right? 350. Okay. Next, let's move to the next question. This is also in 21 exam paper only. For a DC motor, gross mechanical power developed by the motor is maximum and the motor is supplied through a 220 volt source. What will be the back EMF? See, they are asking about power to be maximum. First of all, what is the formula for power generated by a DC motor? It is EB into IA. Okay, there was a small derivation I am doing. Those who remember the condition, they can directly answer it. But in case if you did not remember the condition, within half minute you can derive it. What is the formula for back EMF in a DC motor? Vt minus IaRa, right? So from this, power generated by the machine will be equal to Vt into Ia minus Ia square into Ra. But they are asking about power or maximum power, maximum power. So we know that for the power to be maximum, the differentiation of that power with respect to the variable quantity must be equal to 0. What is the variable quantity in this equation? Whenever load changes, armature current will change. So differentiate this equation with respect to armature current and equate it to 0, then you will get the condition for maximum power to be generated. Then what will be the differentiation for the first term? Vt. For second term, 2IaRa. This must be equal to 0. From this, IaRa should be equal to Vt by 2. Now replace this IaRa in the back EMF equation. What is the formula for back EMF? Vt minus IaRa. And what is the value of IaRa? Vt by 2. So this is Vt minus Vt by 2. So Vt by 2. So the condition for power to be maximum is back EMF must be equal to half of the supply voltage. In the given question, what is the supply voltage? 220. Then what is the half of it? 110. Therefore, the back EMF of the motor must be 110. This derivation is for those who did not remember this concept. In case if you have enough practice and if you already remember the concept, you know condition for maximum power is back EMF must be half of the supply voltage. Okay, maximum power transfer theorem. So therefore, if the supply voltage was 220, yes, the back EMF must be half of it, 110. Okay, so direct answer. Yes, 110 is correct. Somebody said fast sir, no need to teach entire class here. I think you already know these questions. Okay, why to waste the time in live class, right? I request live class is only for those who wanted to have last minute revision. Okay, if you have enough practice, if you already gone through the entire subject, don't waste time, okay, for this live session. All right, you can refer the other subjects also, right? Fine. Next, question number 8. A 220 volt DC shunt motor runs at 630 rpm when the armature current is 50 ampere. Find the speed if the torque is doubled. Assume armature resistance. This is a good question. You see that it was a shunt motor. very much clearly given. It is already running at 630 rpm. Okay, armature current was also given. Now they are asking what will be the speed if the torque is doubled. So two things you can do here. One is answering the question through entire mathematical way, or answering the question smartly. You know that it is a shunt motor. Shunt motor will offer drooping speed characteristics or rising speed characteristics. For example, if you take speed on y-axis and torque on x-axis, yes, it will offer drooping speed characteristics, but the drop is very, very small. Why the drop is very small? Because the only reason for a drop in the speed is IARA drop. Okay, this is known as no load speed omega naught, and this is how the speed will decrease as the load torque is increasing. And the reason for a drop in speed is IARA drop. We all know that armature is usually designed with very small resistance or very high resistance, a very small resistance. Therefore, the drop is also going to be very, very small. Okay, that means, for example, when the load torque is T, let us say the speed is equal to how much given? 630 rpm. 630 rpm. Now they said the torque is doubled. If the torque is doubled, that means T will increase to 2T. Therefore, the speed will definitely decrease. The answer will be less than 630. But the question is, will it decrease by a large quantity or very small quantity? Very small quantity. Why? Because I said IARA drop is very small. Therefore, the answer will be definitely less than 630, but very less drop in the speed. Okay, so therefore, can I say option A is the only choice? Because you see, 315 means almost half of the previous speed. Torque doubled, that doesn't mean speed will be reduced to half. Speed only reduces by a small quantity. Therefore, out of the 4 options given here, only option A is suitable, which shows only 30 rpm drop in the speed. Okay, or else you can do one more thing. If you wanted to prove it mathematically, you can calculate back EMF in the first case. Vt minus Ia into Ra. What is the terminal voltage? 220. Armature current 50. Armature resistance 0.2. So therefore, back EMF was 210. Okay, you know all that torque is Ka phi into Ia. And remember, it is a shunt motor, so flux is a constant value. If flux is a constant value, torque is proportional to armature current, right? Now they said torque is doubled. If torque is doubled, armature current will also be doubled. That means what is a new armature current? 50 ampere becomes 100 ampere. Therefore, the new back EMF will be Vt minus Ia2 into Ra. Terminal voltage doesn't change. New armature current is 100. Therefore, the back EMF was 200 volt. So first case back EMF 210, second case back EMF 200. So final formula, what is the back EMF formula? Ka phi into omega. Flux is a constant value because it is a shunt motor. So back EMF is only proportional to speed. So back EMF in the first case divided by back EMF in the second case will be equal to speed in the first case by speed in the second case. Back EMF in the first case 210, second case 220. Speed in the first case 630, second case is how much? This is the exact procedure. And remember, this will take time. This will kill your time, right, in the examination hall. Okay, so when we need to follow this particular procedure to answer the question, for example, if the 2 options are there very near to 630. For example, I gave you 610 rpm and 600 rpm, both in the options. Then in order to figure out which is the correct answer, this is the original procedure. Find back EMF in both the cases and then find out what is the new speed of the motor. But if the options are having a sufficient deviation, smartly you can answer the question just by looking at the characteristics, speed, torque characteristics of a DC shunt motor. Okay, very important. Shunt motor will offer a drop in speed, but the drop is very, very small. Okay. All right. Yes. Okay. Now let's move to the next question, question number 9. This is also 2021 paper. An alternator has a per unit impedance of 0.9 per unit to a base of 20 MVA 33 kV. Then the per unit impedance to the base of 60 MVA and 11 kV. This is if base values changes, how per unit value changes. I hope most of you have idea. The new per unit impedance will be always equal to the old per unit impedance into the new MVA rating by old MVA rating into old KV rating by new KV rating whole square. This is actually a power system question, I must say. Okay. So according to that, you must understand MVA rating increases, right? 20 MVA to 60 MVA. If the MVA rating increases, this ratio will increase. Next, what happens to voltage value? Earlier it was 33 kV, now 11 kV. Voltage rating is reduced. Voltage rating reduces means this ratio will also increase. Denominator reduces, right? New voltage is less, old voltage is more. So if both ratios increases, the per unit impedance will definitely increase. The answer will be definitely more than 0.9. How much you can directly substitute and find out. So it is 0.9 into what is the new MVA? 60 MVA by old value 20. Old voltage 33 kV by 11 kV whole square. This will be 3 times 3 square 9. This is 3. 9 into 3, 27. So the answer will be, I think, 24.3. Right? 24.3. Yes. Correct answer. Option D. It's a direct question, right? If old per units to new per unit value changes. Okay. Next question number 10. Identify whether the given statements with reference to DC machines are true or false. Swinburne's test. This is the question is about Swinburne's test. Swinburne's test cannot be performed on DC series motor. Swinburne's test is a non-loading test. Yes, Swinburne's test is nothing but no load test, guys. It is a no load test. And what is the purpose of Swinburne's test? It is to find out constant losses of a given DC motor. Okay, Swinburne's test. Yes, Swinburne's test is a no load test. Okay, during Swinburne's test, the machine will be operated as a DC motor, not as a DC generator. And the purpose of Swinburne's test is to find out, to determine rotational losses of a given DC motor. And we all know rotational losses belongs to constant losses. So whatever the constant loss we found at no load condition, same constant loss we can use even under full load condition also. Okay. All right. See, as it is under no load condition, can we operate it on series motor? No. Series motor cannot be operated under no load condition. Therefore, the first statement is wrong. I think correct, right. Just a moment. Cannot be this. Swinburne's test cannot be conducted on DC series motor. Yes, that is a correct statement. Okay. And Swinburne's test is nothing but a non-loading test. You can't expect the same question in the next exam also. In the next exam, they may ask you like that. Identify the correct statement. Swinburne's test is used to determine full load efficiency. No, wrong, because it is a no load test. Swinburne's test is used to determine constant losses. Yes. Swinburne's test is used to determine variable losses. Wrong. Okay, these kind of questions will come. Okay, same exact question cannot be repeated, right? That's why when you are practicing PYQs, what is the most important thing? Not only practice that particular question, you try to figure out how that question can be repeated in next time by a different way. Okay, the question is from Swinburne's test. Immediately you should revise everything related to Swinburne's test so that you can answer the next exam question. All right. So with this 2021 questions completed, let's move to 2022 questions. A 746 kilowatt 3-phase 50 Hz 16 pole induction motor has a rotor impedance of 0.02 plus J 0.015 ohm per phase. Full load torque is obtained at 360 rpm. Calculate the speed at which maximum torque occurs. That means they are asking about NMT value. What is NMT? NMT is nothing but the speed at which maximum torque creates. What is the formula for NMT? NMT is equal to 1 minus SMT into NS. Here, SMT is nothing but the slip at which maximum torque created. What is the formula for SMT? R2 by X2. If you directly substitute 1 minus, what is the resistance? 0.02, reactance 0.015. 0.02 by 0.15, right? 0.15, and synchronous speed is 120 F by P. 50 Hz 16 pole by 16. Okay, so this will become 2 by 15. So 15 minus 2, 13 by 15 into 120 F by P. Okay, so if you simplify, you'll get the nearest answer. Okay, so don't just leave like this, simplify this, you'll get the answer. All right, clear? So 15 will cancel in 120, right? How many times? 8 times, right? 8 times it will cancel. So it is 13 into 8. 8 again will cancel 2 times here. 2 will cancel 25 times here. So the answer is finally 13 into 25. 250, 75, 325 RPM. Right? 325 RPM. That is the answer. So I don't require this 360 RPM data. Everything is not required. They are just asking what is the speed at which maximum torque occurs. NMT value we need. NMT formula directly we have, and just substitute the data, you will get the answer. 325 RPM is the correct answer. Okay. Remember, this formula is valid only if stator impedance is neglected. This SMT formula is valid only if stator impedance is neglected. For example, if stator impedance is given, the entire phenomena will change. You have to change the procedure as well. But that will lead to lengthy calculations. Usually at gate level exams, you can expect that. But these kind of exams, normally stator impedance will be neglected. Okay. So let's move to the next question. Which of the following methods of speed control cannot be used for squirrel cage induction motor? Very simple question. Cannot be used. Which methods cannot be used in squirrel cage induction motor? Yes. Slip power recovery control. Yes, I cannot use it. Why? Because slip power recovery control is a rotor speed control method. Rotor side. That means everything we will do from rotor side. We will see different procedures are there. We will inject some extra voltage into the rotor so that we can modify rotor speed. So for that purpose, rotor terminals should be accessible out of the machine, which is not possible in case of a squirrel cage machine. In squirrel cage, rotor terminals are short circuited, right? We can't access rotor terminals outside. So therefore, slip power recovery control method is not possible. Yes, a stator control method we can use. Stator frequency control method we can use. Stator voltage and stator frequency control method we can use. But slip power recovery control method cannot be used for squirrel cage motor. That means this is the correct answer actually. Because they are asking us which cannot be used. Okay. Yes. Right. Let's move to the next question. In a DC machine, the hysteresis losses are covered under the category of what? Brush losses, electrical losses, mechanical losses, iron losses. Okay. So this is a controversial question, I must say, because D is correct, C is also correct. Why? Because iron losses are basically two types. Iron losses are basically two types. What are those two? Hysteresis loss. Hysteresis loss. Second one, eddy current loss. Okay. And what is the formula for hysteresis loss? Hysteresis loss is generally written as, it is proportional to Bm power 1.6 into F. Eddy current loss is proportional to Bm square into F square. Therefore, you have to understand both hysteresis loss and eddy current loss are dependent on frequency. And what is the frequency of induced EMF? P into N divided by 120 Hz. That means the frequency depends upon speed. Okay, I repeat, hysteresis and eddy current loss depends upon frequency. Frequency depends upon speed. That means ultimately I can say these two losses are dependent on speed. In a DC machine, any loss which is dependent upon speed of the rotor or rotational motion, this comes under rotational loss. This comes under rotational loss. The other name of rotational loss is nothing but mechanical loss. You can call with any name. Mechanical loss, rotational loss, all are same. Therefore, both answers are correct actually here. Iron loss is correct and mechanical loss is also correct. Okay. So I don't know which option they have given in the final key, but in my view, both options are correct only. Yes, hysteresis loss is a part of iron loss and iron loss is a part of mechanical loss. Okay, this mechanical loss is nothing but combination of iron loss, friction loss, okay, and windage loss. All are part of, this iron mechanical loss only. Okay, so both are actually correct. Okay, in a transformer, iron losses are not a part of mechanical loss, but in DC machine, iron loss is a part of mechanical loss. Okay, right. Next, question number 14. With reference to skewing, the question is about skewing of the cage rotor of an induction motor. Identify whether the given statements are true or false. The question is about skewing. What is the first statement? Due to skewing, noise is reduced during operation. Yes, it is a correct answer. Noise, vibrations, cogging and crawling can be minimized by using a skewing mechanism. The locking tendency of the rotor is reduced. Yes, this is also correct. Okay, locking tendency, that is nothing but cogging. The cogging phenomena can be minimized. Okay, can be reduced using skewing mechanism. All right, so both options are correct. So it is true and true. Simple question. Next, in a single phase transformer, the ratio of transformation is 2 and the secondary resistance is 0.24 ohm. Find the resistance of secondary in terms of primary. See, the question is about transformation ratio given. Transformation ratio means what? N2 by N1. Secondary to primary, this is equal to 2. Turns ratio means primary to secondary. Secondary resistance is also given 0.24 ohms. Secondary resistance is also given 0.24 ohms. Now, find the resistance of the secondary in terms of primary. That means we are asked to find out, transfer this secondary resistance to primary side. Okay, when a secondary resistance is transferred to primary side, can I say it will become R2 dash? What is the formula? Anything secondary transferred to primary means it will become primary by secondary whole square into R2. So what is N1 by N2? 1 by 2 whole square into 0.24. It will become 4 times 0.6, right? So therefore, secondary resistance referred to primary, that will be 0.6 ohm. That is option A. Simple question, right? 0.6 ohm. 0.6 or 0.06? 0.06, right? It is 0.06, correct. This is 0.06. Okay. See, so far we have two questions related to transfer of the parameters from secondary to primary, primary to secondary, etc. Right? Yes. In case of slip ring induction motor, external resistors are connected in the rotor circuit to dash the starting torque and to dash the starting current from the supply respectively. See, the question is about relation between rotor resistance and starting torque. we all know that starting torque formula 3 by omega s into E2 square divided by R2 square plus X2 square into R2. This is the exact formula for starting torque when stator impedance is neglected. But we know that usually winding resistance is very small compared to this leakage reactance. Therefore, R2 square can be usually neglected because windings are usually having low resistance. In that case, the approximate starting torque formula will be 3 by omega s into E2 square by X2 square into R2. From this, you can say starting torque is directly proportional to rotor resistance, right? So the moment you add extra resistance into the rotor, what happens to the starting torque? Increases. So therefore, the answer for the first question is increases. Increases. This is wrong. This is wrong. Okay, two options are eliminated. Then the next question is about starting current. What will happen to starting current? For that purpose, you draw equivalent circuit under starting condition. You know, this is the equivalent circuit of an induction motor. This is R2, this is X2. Actually, this is R2 by S. This is the rotor voltage and this is the rotor current. But we know at the time of starting, the slip will be equal to 1, right? At the time of starting. Therefore, this current will become starting current. What is the formula for starting current now? It is equal to voltage by root over R2 square plus X2 square because S equal to 1. Now what they said, adding extra resistance into the rotor. The moment extra resistance is added, R2 value will increase. If R2 increases, the magnitude of starting current will definitely decrease. So the answer for starting current is decreases. Okay, decreases. This is wrong. So the correct answer is option A. Isn't it? The correct answer is option A. Right. Okay, option A. So starting torque will increase because of the extra resistance. Starting current will decrease. I can form few more questions here. What will happen to copper losses at the time of starting? What will happen to efficiency? Okay, like that, a few more questions can be added. You must be able to answer those questions as well. Okay, is it the only way to reduce the starting current? Is adding resistance is the only way to reduce the starting current? No, you can also reduce the starting current by reducing the supply voltage by using auto transformer method, star delta method, or series reactance method. If you reduce the starting voltage, automatically starting current will also be reduced. There are multiple questions I can prepare from a single PYQ, right? Next, another question from 22 paper. Determine the regulation of a transformer in which ohmic loss is 1% of the output and the reactance drop is 5% of the voltage when power factor is unity. See, ohmic loss is 1%. This is nothing but percentage resistance equal to 1%. Okay, and the reactance drop is reactance drop that indicates the percentage reactance. This is equal to 5%. And the power factor is unity. So indirectly, cos phi 2 is equal to 1. Now we are asked to find out what is the percentage regulation. First of all, what is the formula for percentage regulation of a transformer? It is percentage resistance into cos phi 2 plus or minus percentage reactance into sin phi 2. This is the approximate formula. And here resistance value was 1 and power factor is unity, right? That means cos phi 2 was unity. Okay, and sin phi 2 will be 0, right? If cos phi 2 is 1, sin phi 2 will be 0. Therefore, the final answer will be 1%. So simple question, right? Voltage regulation is 1%. You need not to put your pen on paper. You can directly answer these kind of questions. For example, if I say power factor is 0.8 lagging, then you will get a plus sign here. Plus sign must be used for lagging power factor. Minus sign must be used for leading power factors. At unity power factor, anyway, sin phi 2 will be 0, whether it is plus or minus doesn't matter. Okay, yes. Next, a synchronous generator is rated at 40 MVA, 10 kV and 50 Hz. The base impedance of the generator will be how much? They are asking about base impedance. So what is the formula for base impedance? Base impedance is equal to kV square by MVA base, correct? So what is the kV square? It is 10 kV, that is 10 square by what is the MVA base? 40 MVA. So it is 100 by 40, it is 2.5 ohm per phase. That will be the base impedance, 2.5 ohm. Direct formula. Base impedance is equal to kV base square by MVA base. And for a machine, its own ratings are nothing but base values. Okay. So 10 is the kV, 40 is the MVA, and we got 2.5 ohm per phase. All right, easy question. Yes. Next, question number 19. If the percentage reactance of an element is 20% and full load current is 40 ampere, then short circuit current will be dash when only that element is in the circuit. See, percentage reactance is 20%. That means what is the per unit reactance? It is 0.2. Full load current is 40 ampere. Full load current is 40 ampere. Then what will be the short circuit current will be? See here, for example, you have a voltage source like this. Only reactance is available in the circuit. Okay, and there is a sudden short circuit here. Okay, by default, this voltage will be taken as 1 per unit, rated condition. What is the short circuit current they are asking? Can I say short circuit current will be equal to simply V by X only? Because there is no load, right? It is simply V by X. V will be taken as 1 per unit because of its rated condition. X is 0.2. So it will be 5 per unit. Okay, but the answer is not in per unit, the answer is in amperes. Short circuit current was 5 per unit, then what is the ampere value? We all know that per unit current is equal to actual current by base current. From this, actual current will be equal to per unit current into base current. What is the per unit current here? 5 per unit. And what is the base current? That base current is nothing but rated current only. What is the rated current? It is 40 ampere. Full load current is 40 ampere. Okay, so it will be 200 ampere. 200 ampere is the short circuit current. Simple. This is actually question related to synchronous machine. In a synchronous machine, during a short circuit characteristics, we will discuss about it. Okay, because the short circuit current is very high, we will try to induce less voltage inside the machine so that we can control that current. Okay, so that is short circuit current will be equal to 200 ampere. Correct answer. 200 is the correct answer. Yes. Okay. Next question. How many parallel circuits are formed in a 4-point starter? The question is about a 4-point starter. In 4-point starter, how many parallel circuits can be formed? Okay. First of all, you must understand 4-point starter is a type of starter we will use in DC machines. In DC machines, there are 3 types. 3-point starter, 4-point starter, 2-point starter. 3-point starter and 4-point starter we will use for shunt motor. 2-point starter we will use for series motor. But in 3-point starter, the problem is you cannot use a 3-point starter for field flux control method. That's why we will use a 4-point starter, more reliable starting method. In 4-point starter, what we will do is that, okay, I'll try to draw here. First of all, we will use it for shunt machine. Shunt machine means there will be a field circuit and there will be armature circuit, right? Both are connected in parallel. Okay. Now, in parallel to this field and armature circuit, there is one more circuit available known as, holding a coil circuit. There are 2 types of magnets available in starter: holding a coil magnet and overload release magnet. Overload release magnet will be connected in series with machine, in series with mains. Overload release magnet. Okay. This is where the supply voltage will be available, terminal voltage. This is overload release magnet and its duty is to protect the motor against overloading conditions. And this is a holding coil magnet. Its duty is to hold the movable arm at on position throughout the operating period of the motor. This is the field winding of the machine, and this is the armature winding. Now you can understand how many parallel circuits are there. How many parallel circuits are there? Yes, holding coil is a one parallel network, field is another parallel network, armature is another parallel network. So can I say overall 3 parallel circuits are there? Yes. So the answer is 3. For example, if it is a 3-point starter, what will happen? If it is a 3-point starter, you can understand. If it is a 3-point starter, what is the only difference? Entire circuit will be same. Overload release magnet, OR, overload release magnet will be same. But holding coil and field winding both are connected in series. Holding coil and field winding both are connected in series. And this is the armature part of the machine. That means overall, how many parallel circuits are there? Here, 2 parallel circuits are there. Armature and holding coil and field together, 2 parallel circuits. But in 4-point starter, we have 3 parallel circuits. This is a very nice question. Okay, 3 parallel circuits are there. Okay, in 4-point starter. All right. These kind of questions will decide the rankers. Okay, normal questions everybody will answer. These kind of questions, regulation questions, everybody will answer. But these kind of questions is what actually going to decide the rankers and the guys who get the job. Okay, right. Logically, you need to think 3 parallel circuits will be there. Okay, most of the students believe that 4-point starter means 4 parallel circuits. That is wrong. It will have 3 parallel circuits. Okay. Next question. Which of the following statements about DC series motor is incorrect? We have to find out incorrect statements about a DC series motor. It is a variable flux machine. Actually, that is a correct statement. Why? Because in case of DC series motor, flux is proportional to armature current. Because armature current and field current both are same. And whenever load changes, armature current will change. Therefore, flux is also going to be variable. Correct. Its speed versus armature current characteristics is a straight line. Okay. Speed current characteristics. In case of a series motor, I am drawing here. If you take speed on y-axis and current on x-axis, it will be like this. Okay. This is speed current characteristics of a DC series motor. See, when the current is 0, that is no load condition, speed will be infinite. We all know that if you try to operate a series motor under no load condition, dangerously high rotating speed can be achieved. Ideally infinite, practically dangerously high. So is it a straight line or a non-linear line? It is a non-linear line. But they said speed armature current characteristics is a straight line. This is a wrong statement or incorrect statement. Incorrect. That means this is our answer. Okay, they are asking us to find out incorrect statement only. Look at the next one. Its speed is inversely proportional to load current. Yes, this is inverse proportionality curve only, right? It must never run under no load condition. Yes, this is also correct statement. So the only incorrect statement is option B. Option B is the only incorrect statement. Correct? Yes. Easy question. Next, 22. A single phase transformer has 400 primary and 1000 secondary turns. If the primary is connected to 500 volt 50 Hz supply, what is the secondary? This type of question we already answered, right? N1 was given, N2 was given, primary voltage V1 was given, find the secondary voltage V2 is the question. I'm not solving it, you can easily do it. V1 by V2 is equal to N1 by N2. V1 given, N1 given, N2 given, just find out V2. You can easily answer that question. I think 2.5 times 1250 is the answer, right? Directly you can answer. Okay. Next. In DC machines, the method of achieving good commutation with the help of interpoles is called as dash. That is indirectly good commutation. That is improving commutation with the help of interpoles. Okay, you know, to improve commutation there are various procedures. We have resistance commutation, voltage commutation. In resistance commutation, what we will do? We will use high resistance brushes so that the current delay will be reduced and commutation will be improved. In voltage commutation, what we will do? In voltage commutation, by the help of interpole flux, we will induce additional voltage in armature coils which will neutralize reactance voltage. Once reactance voltage is neutralized, arcing can be avoided and commutation can be improved. So improving the commutation with the help of interpoles is what we call it as voltage commutation or EMF commutation. Okay, anything we can call. Resistance commutation is another procedure where we will add high resistance brushes. Okay, that can also be a question. How to improve commutation using the help of brushes? Then that is resistance commutation. But using the help of interpoles, that is voltage commutation. And at this question itself, you try to understand what is the purpose of interpoles in DC machine. Interpoles will perform two important duties. One is to neutralize reactance voltage so that commutation will be improved. Another one is to neutralize cross magnetizing effect of armature reaction. Anything can be expected in the examination. Okay, right. Next, which of the following statement is correct regarding an auto transformer? This time the question is about auto transformer. A part of the winding is common to both the primary and secondary circuits. The two windings are not electrically isolated. Okay, see, auto transformer means it is a transformer having a single winding, right? It is, see, I am giving you a step down auto transformer as an example here. This is supply voltage. Let's say here the load is connected. So what is the point here? A part of the winding, you can see this winding, you can observe this winding from the primary side as well as from the secondary side. So a part of the winding is common to both primary and secondary. This is a correct statement. Second thing, the two windings are electrically isolated or electrically connected. Electrically directly connected, right? There is no electrically isolation. Okay, so not electrically isolated, it is a correct statement. So both statements are correct, right? Both 1 and 2 are the correct statement. They are asking correct only. Sometimes they will ask you incorrect statements. Incorrect statements means neither one nor two. Okay, read the question very properly. We are asked to find out correct statements. So first one is correct, second one is correct. That's why option D is the correct answer. Correct. Yes. All right. Look at question number 25. In potential transformers, the secondary winding is designed so that a voltage of dash is delivered to instrument load. This is actually, from instrumentation subject, or you can say measurements you will study. Okay, potential transformers, PTs we call them as. The secondary winding is designed so that the voltage of dash is delivered to the instruments. Okay. Yes, 100 to 120 volt. What is the purpose of potential transformer actually? The purpose of potential transformer is to measure high voltages, right? To measure high voltages. What is the purpose of, current transformer? Current transformer purpose is to measure high currents. So in this question, voltages are given, right? So you have to answer standard voltages here. I think in measurement subject, probably you will learn it. Some standard voltages you have to measure. I think what are the standard voltages we will usually use in industries for potential transformers? Yes, it will be typically around 100 to 110, right? Standard on secondary side. Okay, so 100 volt to 110 volt typically. Standard, actual standard, secondary side. I think for current transformers on the secondary side, 0 to 5 ampere, some standard will be there. This is the line voltage, a phase voltage will be divided by √3. Okay, so I think 100 to 110. Okay, so according to that, option A should be correct. Right. Okay. So question number 25. Hope the session was running smoothly, no issues. Yeah. All right, guys. Read another theoretical question. You see that. Which of the following is correct regarding distribution transformer? The question is about a distribution transformer. Distribution transformers cannot. I did not understand the question. Cannot the primary system? What cannot? 2.4 to 34.5 kV to the secondary system 480 volt and lower. Okay. Distribution transformer may be installed outdoors on overhead poles, outdoors at ground level on pads, indoors within buildings, or underground in manholes and vaults. It's a logical question. You have to answer with some common sense. First of all, distribution transformer means it is the end of the transmission line or beginning of the transmission line. It is the end of the transmission line, user side, right? Distribution transformer means user side. User side means we know typically our three-phase system will have a 480 volt network. Okay, so the secondary side of the transformer should have 440 volt range. So this is correct, 480 volt and lower. And the primary side will have typically 11 kV, 33 kV, 3.3 kV, 1 kV, 1.1 kV range. It was given. This is also a correct range only. Usually, if you are living in an urban society, your distribution transformer will be typically having 11 kV to 440 volt, right? 11 kV will be the input voltage, 440 volt will be the output voltage. And that 440 volt will be distributed to different phases usually. So input 11 kV. Sometimes you can give 33 kV also in industry level, okay? Or you can give 3.3 kV, 1.1 kV, not more than 33 kV usually. So therefore, first statement is completely correct. Also, they said distribution transformer may be installed outdoors on overhead poles. Yes, you will see roadside on the poles. Distribution transformer will be used. Ground level on pads. Yes, you can install in the ground level also. Within the buildings, if it is a commercial building, generally in the parking lot, you can see a transformer. Manholes and vaults. I have never seen a transformer in manholes. Maybe at the mining level they might have done. Okay, at a mining level, that means mining industries, a lot of drillers will work, right? Okay, for the drilling machines you generally need a transformer. At mining level you might have seen in manholes and vaults a distribution transformer might be used. So just to use common sense to answer that, I think probably second statement will also be correct. Okay, there is no formula to answer this. Just by using common sense we have to answer. So I think both answers are correct. Yes. Yes, we are asked to answer the correct statements only. So both statements are correct. Yes. Okay. Next, which of the following statement is correct? Short circuit test. This test serves the purpose of determining the series parameters of a transformer. Open circuit test or no load test. The purpose of this test is to determine the shunt branch parameters of the equivalent circuit. I think both are correct only. Short circuit test is used to determine series branch parameters. Correct. Open circuit test is used to determine shunt branch parameters. Correct. Both are correct statements. Okay. I may change the question. Short circuit test is used to determine iron losses or copper losses. Copper losses. Open circuit test is used to determine iron losses. Okay. Not only winding parameters, we can also find out power losses using the open circuit and short circuit tests as well. Okay, that way also a question can be generated. Easy question. Next, which of the following statement is correct regarding cooling method of transformers? Oil immersed self-cooled. In this type, the whole transformer is immersed in a tank of oil. Correct. Entire transformer will be immersed, correct? Next, oil immersed forced cooling. This is self-cooling. Forced cooling means a fan or motor will be there to rotate the oil. Okay. Oil immersed forced cooled. In this type, a plain tank is used and oil is cooled artificially either by tube immersed in oil through which cool water is forced, or preferably by circulating the oil by pump. Yes, circulating the oil by pump. I told you that. Okay. In large rated transformers, self circulation of oil may not cool down the transformer so quickly. So in order to circulate oil, in a quick manner, we will use a pump. That pump will circulate the oil. It will suck the oil from the tank. It will push the oil into the tank. Hot oil it will suck. Externally we will cool that oil, and then the cold oil we will immerse into the tank. For them, a pump is required, okay, through an extra cooler. Yes, both transformers are correct only. Both are correct. Okay. Self-cooled transformers you will normally see at a distribution level. If you have an apartment, your apartment will have a transformer, right? And do you see any pump attached to the transformer? No, it's self-cooling. The entire transformer will be immersed inside the tank. The tank will be filled with oil. Okay, so both statements are correct. I think same question is repeated again. Maximum efficiency in a transformer occurs when? When do we get maximum efficiency from a transformer? Yes, maximum efficiency means variable loss must be equal to constant loss. Okay. Variable ohmic loss is equal to fixed core loss. Correct. That is the correct answer. So maximum efficiency will occur at a load where variable loss is equal to constant loss. If you want condition that a loading X will be equal to square root of iron loss divided by full load copper loss. Yes, this X will represent the per unit load at which maximum efficiency can be achieved. Okay. This is a straightforward question. Again, we have a question from potential transformers. Okay. This is a question again related to measurements topic, but you can answer here. Potential transformers are used to operate voltmeters, the potential coils of wattmeters, and relays from high voltage lines. Yes, what is the purpose of potential transformer? To measure high voltages. Therefore, the first statement will be definitely correct. Okay. Look at the second statement. The design of a potential transformer is quite similar to that of power transformer, but the loading of a potential transformer is always small, sometimes only a few volt ampere. Yes, that is also correct. See, the design will be similar to normal transformer. It will have two windings, primary winding and a secondary winding. A core will be there. The design will be very much similar to power transformer, but the loading is very, very small. Why? Because the purpose of potential transformer is just to measure the voltage. That means the load on the secondary side of a potential transformer will be a small voltmeter. It's a very small voltmeter. That's all. It will be just used to measure the voltage. And voltmeters will have a infinite amount of impedance. Ideally, practically very high impedance. Therefore, voltmeters will draw very less amount of current. Okay. So if you look at a potential transformer, this is the primary and this is the secondary, and the secondary will be connected to voltmeter. Primary will be connected to the source. Okay, so this is very high voltage, this is very low voltage, and this voltmeter will draw almost zero current, right? Ideally, voltmeter means open circuit. Practically very small current it will draw. So therefore, the loading on the secondary side of a potential transformer will be very, very small. Therefore, both statements are correct. Yes, potential transformers are used in high voltage lines, and they are used to measure the voltages by using the help of voltmeter. Okay, so first statement is correct and the second statement was also correct. Both statements are correct here. Okay, both statements are correct. Right. These are intelligent questions. Okay, these kind of questions one should be able to answer logically. You need to think. Okay, and then you have to answer the questions. Okay, next, compound DC motors are used for what? Pulsating loads needing flywheel action, plunger loads, pumps, shears and conveyors. For what type of loads compound motors are used? Generally, what is the purpose of a compound motor? First of all, come on. Compound motor means it's the combination of shunt motor and series motor. Okay, shunt motor means the speed change was very less. Series motor means it will be used to create high starting torque. Therefore, compound motor is used where high starting torque and finite no load speed. Both characteristics must be satisfied. Okay, that is the combination of shunt and series. Now you see that they are asking pulsating loads. Pulsating loads are also known as intermittent load applications. Intermittent load applications. Intermittent load applications means few minutes the load will be present, next few minutes load will be off, again present, again off, again present, again off, like that. Load is on and off type. See, here you cannot use a series motor. Why? Because the moment when the load is off, the motor will be under no load condition, and series motor cannot be used for no load application. Also, you cannot use shunt motor. Why? Because they need high torque. Whenever flywheel action is needed, high torque is required. Therefore, you can go for a compound motor here. Okay, even for plunger loads, shears and conveyor belts. Okay, conveyor belts. Okay, lift applications where you need high starting torque and also finite no load speed, you can go for compound motor only. Yes, this is application of compound motors. Yes, you can use in all these kind of loads. Pulsating loads, everybody has to focus here. Pulsating loads are also known as intermittent loads. Intermittent loads means we can use only compound motor. Okay, for shears and conveyors, you can use a series motor or compound motor. Anything you can use because both can give you high starting torque. Plunger loads, you can use compound motor or shunt motor also, because these loads will normally rotate at constant speed. For the speed to be constant, you can use a shunt motor as well as compound motor. But the question is about, but here pulsating loads, only compound motor. Only compound motor. So in all three applications, compound motor can be used. Therefore, my choice will be all 1, 2 and 3. All can be used. Right. Clear? For conveyor belts also, compound motor can be used. Okay, tap changing transformers. Probably you might have studied in power systems concept. What is the answer for this question? Just read the question first of all of you. Many distribution substation transformers have load tap changers because load tap changers. Yes, load tap changers manually regulate frequency level based on loading condition. Load tap changers automatically regulate voltage levels based on load conditions. Load tap changers does not regulate voltage levels based on loading conditions. Load tap changers manually regulate voltage level based on loading conditions. So what is the answer? First of all, tap changing transformers are used for voltage regulation control, right or not? Voltage regulation control. Tap changing transformers are used. Tap changing transformers are used for voltage regulation control. You cannot control frequency using tap changing transformers. We can use only, or we can control only voltage levels. You can increase the voltage or decrease the voltage based on the amount of load. And it is an automatic procedure. Okay. It will control automatically. Manually, we cannot control every now and then. Okay, so it is a manual process, sorry, automatic process. All right. Load tap changers, substation level tap changers are usually manual control, but at the load end usually automatic controls are used so that we can control voltage regulation every now and then. Okay, yes, clear? Yes, please write that point. Don't guess your answers, you should have valid reason for every question. Okay, yes, tap changing transformers are used for voltage regulation control purpose only, and it is an automatic process. 24/7 they must monitor voltage regulation, and whenever voltage increases, tap rating must be reduced. Whenever voltage decreases, tapping must be increased. So likewise, they have to monitor the voltage at the load end and they have to control it. Okay, yes, all right. Next, in a DC series motor, the starting torque is very high up to dash times of the full load torque. Up to what time? Starting torque is very high up to dash times of full load torque. I can't say it is a relevant question actually. It is very high. Why series motor starting torque is very high and dash times up to full load torque means, see, generally torque is equal to Ka phi into Ia. But in series motor, flux is proportional to armature current. Therefore, torque is proportional to Ia square. Now they are asking about starting torque. So starting torque is proportional to starting current square. For example, if starting current is 2 times of full load current, starting torque will be 4 times of full load torque. If starting current is 4 times of full load current, starting torque will be 16 times of full load torque. So is it 3 times or 4 times or 2 times or 5 times? I can't exactly answer how many times unless I know how much is the amount of current. Are you understanding? Okay, so this is not a relevant question. I must say the question itself is wrong. How can we answer without the information of the current? Starting current is how many times of full load current? Okay, if starting current is how many times of full load current was known, then starting torque how many times of full load torque we can answer. I can't predict, see, in series motor it is 2 times only, 3 times only or 4 times only. We can't answer like that. So it's not a relevant question. Data missing, I must say. Data is not sufficient. Okay. You can ask ChatGPT this question, it will definitely give one answer, but that is not correct. Okay, because in 1 or 2 books this question might have been written. What is ChatGPT? It's all about data. It will just go through all the books and wherever this question was there, it will give that answer. Okay, so data is not sufficient, guys. Without knowing the information about current, we can't answer how many times the torque is going to be. Okay, DC shunt motor has dash starting torque. Yes, it will be a self-starting motor. Definitely finite starting torque will be there, but it is a minimum. DC shunt motor will have less starting torque. Why? Because in shunt motor, flux is constant. Same formula. Torque is equal to Ka phi into Ia, but flux is a constant value. So torque is only proportional to Ia. But in series motor, torque is proportional to Ia square. So that's why shunt motor will create less starting torque compared to series motor. So therefore, I must say it will have minimum starting torque. If you want maximum starting torque, we have to go for series motor. Medium starting torque, you have to go for compound motor. Compound motor will give you medium torque. Series motor will give you maximum starting torque. Shunt motor will give you minimum starting torque. No motor will give you zero. All DC motors are self-starting motors. Therefore, starting torque is definitely finite, but whether it is minimum or maximum depends upon the type of the motor. Okay, depends upon the type of the motor. Okay. So let's have a short break for 5 minutes. Then we will continue. We have another 30 questions. Take a break for a short duration. Then we will continue. All right, guys, welcome back. So let's continue our discussion. So we'll be moving to question number 36 now. Yes, read the problem. Which of the following statement is correct about a slip ring induction motor? Starting torque is higher and 3 times the full load torque. Starting current is lower and is 2 times the full load current. What these questions? The question is about a slip ring induction motor. Starting torque is higher. This is acceptable. Why? Because in slip ring induction motor, starting torque is proportional to rotor resistance. By adding extra resistance into rotor, we can increase the starting torque. This is acceptable. But it is 3 times the full load torque. Exactly 3 times I can't conclude. Okay. What is the relation between starting torque and full load torque? Starting torque divided by full load torque is equal to starting current divided by full load current whole square into slip under full load condition. Okay, so it all depends upon the starting current value, right? If starting current is 2 times of full load current, the square will become 4 times. Like that, it depends upon the value of the current. Exactly 3 times or exactly 2 times, I can't answer. For example, if you assume second statement is correct, starting current is lower. Why? Because we are adding extra resistance and it is 2 times the full load current. For example, if really starting current is 2 times the full load current, if I substitute that here, 2 times the full load current by full load current whole square into slip at full load, then it will become 4 times of slip at full load. This is starting torque by full load torque. Again, it depends upon full load slip only. At least, let's take another assumption here. Usually, induction motors will operate from 1% to 5% range slip. Let's take slip is 4%. Even if I take 4% slip, 0.04, then it will become 0.16. Okay. So, starting torque will become 0.16 times of full load torque, which is less than 1, right? This is an assumption only. Usually, induction motors range of slip will be from 1% to 5%. I took 4% average slip. So in that case, starting torque is less than full load torque. Okay. So therefore, starting torque is higher, but 3 times of full load torque is not going to be possible. Okay. If starting torque has to be 3 times of full load torque, if this product has to be 3, okay, that means what should be the value of a starting current? In that case, 3 by 0.04, 300 by 4, approximately 100, almost 10 times. If a starting current is a 10 times of full load current, then this ratio will become 10 square 100. 100 into 0.04 will become 4 times. At least if not 10 times, 7 times or 8 times the current must be there. Okay, so therefore first statement was wrong, second statement may be correct, but that too I can't predict. Okay, again, data is not sufficient for this. Okay, if I assume the second statement is correct, first statement will be definitely wrong. Okay, if you assume the first statement is correct, second statement will be wrong. Current will be 10 times or 7 times or 8 times like that. Okay, so it's exactly not possible to think about how many times, okay, without giving proper data. Okay, clear? For me, first statement is definitely wrong. Second statement possibility is there. Why? Because generally we will design the machine to withstand current which is 2 to 3 times of rated value. Okay, so second statement is probably correct. First statement will be definitely wrong. So my vote is only for option A. My vote is only for option A because we have to choose one answer. Okay, because current to 2 times, yes, the motor can withstand, no problem. Okay. Next, which of the following statement is correct regarding a DC shunt motor? At low speeds, DC shunt motor are comparable with synchronous motors. The outstanding feature of DC shunt motor, however, is its superb wide range flexible speed control above and below the base speed using a solid state control rectifiers. Yes, both statements are correct. Why? Because they are talking about DC shunt motor. If you look at the torque speed characteristics of DC shunt motor, I already discussed in one of the problem. For example, if this is no load speed, then as the load torque increases, speed will reduce, but the drop is very, very small. What is the only reason for a drop in speed? IARA drop. If you neglect that IARA drop, the speed is almost constant. Speed is almost constant. So when I say speed is almost constant, yes, it will behave like a synchronous motor, especially at lower speeds. At lower speeds, the change in speed becomes much smaller value. Therefore, the machine will behave like a synchronous motor. Okay, this is correct. Also, the advantage with the DC motor is a wide variation of speed control. By using armature resistance control method, we can reduce the speed. By using field flux control method, we can increase the speed. So, wide range of speed control is also possible. That means both 1 and 2 are the correct statements. Okay, logically you have to answer it. Clear? Yes. Both are the correct statements. Next. In slip ring motors, starting current is dash and the starting torque simultaneously dash by adding an extra resistance in the rotor circuit. We already studied, right? By adding an extra resistance in rotor circuit, starting torque will be simultaneously increased. Okay, because starting torque is directly proportional to rotor resistance. What about starting current decreases? Why starting current decreases? Because I gave you the circuit diagram also. This is the circuit diagram of induction motor at the time of starting. This is the rotor voltage. This is the rotor current at starting. So if you write equation for this starting current will be equal to voltage divided by impedance R2 square plus X2 square. So whenever you add extra resistance into the rotor, the magnitude of the starting current decreases. So the starting current decreases and starting torque increases. So the correct answer is reduced and increased. C. Simple question. Right. Keep posting your answers so that the session will be more lively, right? Okay. Next, the interaction of rotor currents with rotating flux wave produces dash in the rotor of a three-phase induction motor, and as a consequence, rotor begins to rotate. See, interaction of rotor current with rotating flux, it will create the torque. Okay, isn't it? It will create the torque because the Lorentz force equation. What is the Lorentz force equation? Whenever a current carrying conductor is placed inside a magnetic field, it will experience a force. And what is the magnitude of the force? BIL sine theta. So whenever magnetic flux and current carrying conductor interacts with each other, a force will be created. Linearly we call it as a force, angularly we call it as a torque. Because of the torque only the machine will rotate. And most importantly, here the magnetic field is created by stator and the current is passing through rotor. Mutual induction. Okay, stator flux, rotor current, and then the torque will be created. Because of the torque, the machine will rotate. Clear? So the answer is torque. Lorentz force equation. Okay. Yes. Next, the swing equation of a synchronous machine. I don't know exactly the answer for this. This is actually power system question. I forgot what is swing equation. I think I can try to answer. Swing equation is a power system question. By mistake, it was added here. It is analyzes the friction and windage loss, determines steady state stability, describes the rotor dynamics of synchronous machine, is a linear second order differential equation. I think it is a second order equation, right? Also, it will let us know about the rotor swings around the steady state synchronous speed. Okay, I'm not so sure about this answer. I think it is a second order equation. Yes. All right. If I am wrong, please correct it. I don't know exactly. I forgot actually swing equation, power system stability, etc. topics. Okay. Yeah. Which of the following is determined by the slip test? Actually, slip test will be conducted on salient pole machine, right? On salient pole machine. And what is the purpose of slip test? To determine direct axis reactance and quadrature axis reactance. What is the formula? Direct axis reactance will be equal to V max by I minimum ohm per phase, and quadrature axis reactance will be equal to V minimum by I maximum. In case if there is a numerical question, this will help you. But the purpose of slip test is to find out both direct axis reactance and quadrature axis reactance. Okay. I can ask few more questions. During slip test, rotor will be rotated at a synchronous speed or asynchronous speed? Asynchronous speed. Okay. Yes. Right. Next. A DC series motor is rated 230 volt, 1000 rpm, 80 ampere. The series field resistance is 0.11 ohm and armature resistance is 0.14 ohm. If the flux at armature current of 20 ampere is 0.4 times of that of under rated condition, calculate the speed at this reduced armature current of 20 ampere. See, initial speed was 1000 rpm, guys, and that is at a current of 80 ampere. Now, next time the current is reduced to 20 ampere, what is the new speed they are asking? Very simple, two cases are there. In both cases, we will try to calculate back EMF. So what is the formula for back EMF in the first case? It is a series motor. Vt minus Ia into armature resistance plus series field resistance. What is the terminal voltage? 230. Armature current was 80. Armature resistance is 0.11. Field resistance 0.14. Okay. So it is 0.11 plus 0.14. It is 0.25. It will become 20. So 210 volt. This is the back EMF in the first case. Now calculate the back EMF in the second case also. What is the back EMF in the second case? Vt minus Ia2 into Ra plus Rf. Vt doesn't change, 230 minus, but this time armature current was 20 ampere only. 20 ampere into 0.11 plus 0.14. Okay, so it will become 225 volt. So I got back EMF in both cases. Now the moment you got back EMF, you can write down directly back EMF formula. Ka phi into omega. But remember, it's a series motor, so flux is not constant, it is variable. Back EMF is proportional to flux into speed. First case back EMF by second case back EMF is equal to first case flux by second case flux into N1 by N2. What is the back EMF in the first case? 210. This is 225. Now see that it is given in the first case current is 80, guys. When current reduced to 20, flux becomes 0.4 times of the previous value. That means if first case flux is 5.1, second case flux is 0.4 times of 5. First case speed is 1000, second case speed we have to answer. This is crucial, guys. The new flux is 0.4 times of the previous flux. That was given in the problem. I'm not assuming anything. So our requirement is to find out the new speed that will be equal to 225 by 210 into 1000 by 0.4. See, 225 by 210, almost just more than 1. Just more than 1 means you can try, approximate answers you try, so that nearest option you can select. See, denominator 210, let us assume 200 only. If it is 200, what is 200 into 0.4 will become 80, right? So it will become 225 into 1000 by 80. Okay, almost, is it correct? 200 into 0.4, 20 into 4, 80. 225 by 80. Approximately, it will cancel for 2.5 to 3 times. If it is a 3, answer is near to 3000 rpm. I think 2678 would be the nearest answer. right? Approximately 80 this is. 225 by 80. 3 times 240 must come. 225 less than 3. So answer is less than 3000 RPM. Less than 3000 RPM, I have a nearest answer 2678 RPM. Okay. It's a little lengthy question, but you can easily answer. Okay. Right. 2678 is the nearest answer. Okay. Okay, someone said me swing equation is a non-linear equation. I think I answered it is linear. I think it is not linear. Correct. If this is not true, I think it will describe the rotor dynamics probably, because it will represent the swing, right? I am not sure about that question. I'm being honest. I forgot actually what is swing equation, stability of equal area criterion, etc. You please go through it later. Okay. All right. Anyway, 2678 RPM is the correct answer. Okay, let's move to the next question. Full load regulation of a single phase transformer found using a short circuit test data gave a negative value. What is the power factor of the load considered for the calculation? See, full load regulation of a single phase transformer found using short circuit test data. We know that short circuit test data will give series branch parameters. That is, it will give percentage R value and percentage X value, correct? But full load regulation measured using these two values will be negative. Generally, if you look at voltage regulation curve, this is positive voltage regulation, this is negative voltage regulation. This side lagging power factor, this side leading power factor. Here you have unity power factor, and this is how voltage regulation curve looks like. This is the negative regulation points. And this negative regulation you can understand for leading power factors only. That too, not all the leading power factors, some of the leading power factors. Okay. So definitely the answer is leading. That too, not all leading. Here you have zero regulation. This range will have positive regulation, but this range of leading power factor will have negative voltage regulation. Okay. So answer is leading. Okay. Right. Next. 2200 volt by 110 volt 50 hertz single phase transformer has equivalent resistance of 0.02 per unit and equivalent reactance of 0.08 per unit. What will be its full load regulation when supplying a load of 0.8 power factor leading? So once again we are asked to find out regulation. What is the formula for percentage voltage regulation? Percentage R into cos phi 2 plus or minus percentage X into sin phi 2. What is the percentage resistance? Per unit 0.02. So percentage will be 2. 2 into what is the power factor? 0.8 power factor leading. That is 0.8 minus, right, leading power factor. Reactance 8%. If cos phi is 0.8, sin phi will be 0.6. So 1.6 minus 2.4. Sorry, 4.8. How much? 3.8. 3.2 percentage minus. Correct? Yes, minus 3.2 percentage. Yes. Easy question. Minus 3.2 percentage. Any calculation mistakes if I commit, please let me know in the chat box. Yes. Next. What is the maximum possible VA rating of an auto transformer delivered from a 2-winding transformer of rating 240 by 120? Okay. You know, VA rating of auto direct formula is equal to 1 by 1 minus K times of VA rating of 2-winding transformer, where K is nothing but LV by HV of auto transformer. First of all, what is a 2-winding transformer given 240 by 120? One winding 240 rating, another winding 120 rating. So you can connect it in two ways, right? For example, if you take 240 here and a 120 volt winding here, so that both voltages are adding, then output will become 360. Here K will become 240 by 360. There is another way. You can take 120 volt winding common, then 240 volt winding you can add here, then you will get output 360. Now what is the value of K? 120 by 360. But if you want maximum possible VA rating, K must be as high as possible, right? If K is high, then only maximum VA rating is possible, right or not? Therefore, 240 by 360K is acceptable, 120 by 360K is not acceptable because it cannot give you maximum VA rating. So if you directly substitute that, so the VA rating of auto transformer will be 1 by 1 minus 240 by 360 into what is the VA rating of two winding transformer? 200 VA. That's all. It will become 360 minus 240, 120. I think it will cancel 3 times. So 600 VA is the, okay, that is the maximum VA rating you can get. I repeat that question again. When you convert two winding transformer to auto transformer, two possible VA ratings will be there. But the question is to find out maximum VA rating. That means K must be as high as possible. If K is high, then VA rating will also be high. So the acceptable K limit will be 240 by 360. Correct? 240 by 360. In that case, the VA rating of auto transformer would have been 600 VA. Okay, this is a standard question from auto transformers. Okay, look at this question. All day efficiency is defined based on which of the following parameters? Energy, right? All day efficiency is also known as energy efficiency. Energy efficiency. It depends upon power and time. Energy is equal to power multiplied by time in hours, and the unit will be kilowatt hours. Okay. Yes, all day efficiency is also known as energy efficiency. That is straightforward question. Next. One more question we have from transformer subject. A 400 volt by 100 volt 20 kVA two winding transformer is employed as an auto transformer to supply 400 volt circuit from 500 volt source. This is auto transformer rating indirectly. 400 one side, 500 one side. As a two winding transformer at rated load with unity power factor, its efficiency is 0.95. What is the percentage efficiency as an auto transformer? Remember one thing, when you convert two winding transformer to auto transformer, the efficiency will definitely increase. Okay, I repeat again, when we convert a two winding transformer to auto transformer, the efficiency will definitely increase. Okay, therefore the answer is definitely more than 95%. Okay, that means this is wrong answer, this is also wrong answer. The answer should be either 96.8 or 98.9. But what is the correct answer means we have to solve it. Okay, first we will take two winding transformer. It will be little lengthy, but you see, in a two winding transformer, what is the formula for efficiency? VA rating into cos phi 2 divided by VA rating into cos phi 2 plus total loss. That is indirectly iron loss plus copper loss. Okay. What is the efficiency? 0.95. What is the VA rating? 20 kVA. I am directly substituting K. Therefore, the loss is also in kilowatt only. Power factor is unity. 20 kVA unity I don't know the total loss. So you can separate the total loss value from here. So without calculator, it will be quite difficult. 20 by 0.95 minus 20 kilowatt. This is the total loss when the transformer is a two-winding transformer. Now the point is, when you convert this two-winding transformer to auto transformer, total loss doesn't change. Total loss in kilowatt doesn't change. Doesn't change. Okay, I think while studying auto transformer, you will learn it. Okay, but the VA rating will change, right? When two-winding transformer is converted into auto transformer, let me finish this. I need a calculator here. In examination hall, you may ask me, sir, how to answer. I don't know how to answer. I already eliminated two options. Highest efficiency will be probably the answer. Let's see. This is 1.05, approximately 1 kilowatt. Okay, these kind of calculations, just to do approximate calculations, sufficient. Okay, 1 kilowatt approximately. Now let's convert this two-winding transformer to auto transformer. What is the VA rating of auto transformer now? Formula 1 by 1 minus K into VA rating of two-winding transformer. What is the K value? I told you, LV by HV of auto transformer. Here LV was 400, HV was 500. So it is 4 by 5. So 1 by 1 minus 4 by 5 into VA rating of two-winding transformer is 20. So 5 times it will become 100 kVA. See, the VA rating of auto transformer is 100. Now what will be the percentage efficiency? It is the VA rating into cos phi 2 by VA rating into cos phi 2 plus total loss. What is the new VA rating? 100, right? 100 into unity power factor. I am trying to find out efficiency at the same power factor, divided by 100 into unity power factor. Can I use the same total loss? Because when you convert a two-winding transformer to auto transformer, the full load loss doesn't change. Okay, it will be same 100. Okay, so is it looking like 100 by 101? 100 by 101 percentage means 100 percentage. Okay, is it almost near to 100%? 100 by 101 means very near to 100. So the most probable answer is 98.96. I'm expecting. Yes, 98.96, almost 99%. So in examination hall, how to answer such kind of questions? First thing, when a two-winding transformer is converted to auto transformer, efficiency will definitely increase. First thing, forward. Efficiency definitely increases means answer is more than 95%. These two options are eliminated, but there are two options. Then how to choose the correct answer without solution means always you think about VA rating. Two-winding transformer VA rating was 20. The moment I convert that to 20 to auto transformer, it becomes 100. VA rating becomes 100, 5 times more. As VA rating increases by 5 times, definitely efficiency will increase by a lot. Okay, it will significant improvement in efficiency will be there. That is how usually highest efficiency will come. But if you want exactly, this is how to answer it. Okay, one note point everybody has to write down here. When a two-winding transformer is converted into auto transformer, full load loss, the total loss in kilowatt doesn't change. Per unit loss may change, but actual loss doesn't change. Very important. When a two-winding transformer is converted to auto transformer, total loss in kilowatt doesn't change. The magnitude of the loss will be same, but efficiency will increase. Why? Because VA rating changes. Okay. Yes. In which method of control of AC output, the method does not produce a harmonics at low output voltage levels? So So indirectly they are asking lower harmonic levels. Which method will produce less harmonics is the question. Yes. Pulse width modulation, AC voltage control, DC output control, multiple pulse width modulation. Anybody studied pulse width PWM techniques? Okay, straightforward answer is DC control, right? Pulse width modulation, these are all AC control methods. But if you wanted to have less harmonics, definitely DC control method will give you less harmonics because DC doesn't have harmonics in it. Okay. DC output control. That will give you less harmonics. Whenever you are controlling AC voltages using inverters or anything, usually harmonics effect will be there. Okay. DC control is the answer. Right. Calculate the synchronizing torque if two alternators are connected in parallel. Displacement angle is given pi by 45. Synchronizing power 500 kilowatt. Synchronizing reactance 0.5 ohm. Speed of the alternator 1000 rpm. What is the synchronizing torque they are asking? So just a minute. Yes, synchronizing torque. See, synchronizing power is equal to 2 pi nt by 60. Generally, power is equal to 2 pi nt by 60. Okay, if it is synchronizing power, this will be synchronizing torque. From that, synchronizing torque is equal to 60 by 2 pi n into synchronizing power. This n is nothing but synchronous speed. Okay, so 60 by 2 pi, what is the synchronous speed given? Synchronous speed was 1000 rpm into the synchronizing power was given, right? What is the synchronizing power? Synchronizing power is 500 kilowatt. As it was directly given, I don't need how much angle, the phase angle difference is there. Okay, so how much is synchronizing power? 500 kilowatt. Kilo means 10 power 3, 1000. So this 1000 will cancel. So 60 into 500 by 2 pi. Okay, 2 will cancel 30 times. 15,000 by pi. Okay, so pi is 3 point something, right? If it is 3, it would have been 5,000. 3 point means it is less than 5,000. Less than 5,000 means 4775 is the answer. Correct? Any calculation mistakes, please let me know. Yes. This is less than 5,000 Newton. That is 4775. Nearest answer. Okay. Simple. Power is equal to 2 pi nt by 60. If it is synchronizing power, this will be synchronizing torque. That's how synchronizing torque is separated. Clear? All right. If a transformer is operating with a rated voltage and a rated variable frequency, which of the following losses can be considered as a variable loss when supplying a fixed load? Okay, so when I say fixed load, indirectly VA rating is constant. Okay, so what is the formula for VA rating? VA rating is equal to voltage into current. Here VA rating is constant because of fixed load. Also, transformer is operating with rated voltage. Voltage is constant. When voltage is constant, VA rating is constant, indirectly current is also constant. The moment I say current is constant, the copper loss is constant. Copper loss is constant. Okay, copper loss is constant. But who is variable here? Frequency is variable. Voltage is constant, but frequency variable. Therefore, V by F ratio is variable. Correct or not? Voltage is constant, frequency variable. Therefore, V by F ratio is variable. When V by F ratio is variable, what is the formula for hysteresis loss and what is the formula for eddy current loss? Yes, hysteresis loss will be proportional to V power 1.6 into F. Eddy current loss will be proportional to V square. These are the formulas for hysteresis loss and eddy current loss when V by F ratio is variable. Now, whenever frequency changes, hysteresis loss will change. Okay, so hysteresis loss is variable. What about eddy current loss? Constant, because it only depends upon voltage. Voltage was constant, so eddy current loss is constant. So the correct answer can be considered as variable loss. Variable loss means only hysteresis loss. Most of the students, without reading the question, they'll answer variable loss means copper loss. But what is the data given in the question is important. Transformer is feeding fixed load. When I say load is fixed, indirectly, the volt ampere power is fixed. Volt ampere power is fixed, voltage is fixed, so current is a constant value. Copper loss is constant. Only the hysteresis loss will be the variable loss. Clear? Right. Only hysteresis loss is the variable loss. Correct answer. Okay. Next. The intercept of the plot of core loss per cycle of a single phase induction motor against the frequency is found to be 0.5 and the slope of the plot is calculated to be 0.005. What are the hysteresis and eddy current losses respectively at 60 Hz? See, the plot was drawn as a core loss per unit cycle versus frequency. You know that if you take core loss per frequency with respect to frequency, it will be like a straight line cutting the y-axis at a particular point. This is separation of iron losses using open circuit test. And this intersection point is nothing but a constant A, and the slope of this particular graph is nothing but constant B. Yes, iron loss is equal to AF plus BF square. If you divide both sides with F, you will get this formula. It is like Y is equal to mx plus C. This iron loss by frequency is on y-axis and frequency is on x-axis. Then this is a constant and this is the slope. Okay, what is given here? Against the frequency is found to be 0.5. This is the intersection point. A is equal to 0.5. Slope of the curve, where is it? Slope of the curve 0.05. B is equal to 0.005. Now we are asked to calculate what? Hysteresis loss and eddy current loss. What is the formula for hysteresis loss? Hysteresis loss is equal to A into F. 0.5 into, at 60 Hz we have to find out. This is 30 Hz. Eddy current loss formula B into F square. B is 0.005. Frequency 60 square. That is 3600. 3.6 into 5. I think 18, sorry, this is watts, right? This is 18, probably, I'm not sure. Yes, 30 watts is 18 watts, correct. B is the answer. 0.005 into 3600, that is 5 into 3.6. 5 into 4 is 20, 3.6 means less than 20, 18 correct. So 30 watt and 18 watt is the correct answer. Right? See, almost all topics are covered by, we solved almost 51 questions so far. Almost every topic is covered, right? Every topic, most of the topics are covered. Next, the power input of a 20 kVA 50 Hz single phase transformer is found to be 810 watt under no load condition. Okay, power input at no load condition, this is nothing but iron loss indirectly. Okay, when loaded to about 50% of its rated load, the power input was found to be 250 watt. This time the machine is loaded, that means 50% loading, the input was found to be 250 watt. At what output its efficiency will be maximum? Okay, see, no load input was given. This was 810 watt. That will be iron loss, right? Okay. Iron loss is equal to 810 watt. This is no load power. Next, when loaded, machine is loaded, that to how much loading? 50% of its rated load, that is half load indirectly. The power input was found to be 250 watt. 250 watt is wrong, guys, because iron loss itself is 810 watt, right? Then iron loss plus copper loss together, it must be more than 810. 250 watt is wrong. I think it's a typing error. Are you understanding that? Somebody said B is the answer. How did you get B, Mr. Mohan? Iron loss is okay, 810 watt. Under half load condition, power input was 250 watt. That is wrong, right? If iron loss alone is 810, it must be 2500 at least. Right or not? It should have been 2500. Maybe typing error. One more zero must be there. At least try with that. So iron loss plus 0.5 square into full load copper loss was 2500. Because half load, right? Half load means iron loss is there, also copper loss is there. Okay. In that, iron loss is already 810. This is 0.25 times of full load copper loss is 2500 watt. From this, what is the copper loss at full load? You take 810 to the right side. I'm getting full load copper loss 6760 watt. I'm not sure about the question. When loaded very clearly to about 50% of rated load, the power input was okay. Maybe I think it's a question typing itself is an error. It's not a correct data, right? Are you guys getting the points? Isn't it? Or else at least it is only copper loss information. When loaded to about 50% of its rated load, it is not loaded, it must be short circuit. When short circuited to 50% of load, then it is 2250. They should not use the word called loaded. Loaded means iron loss will be there, copper loss will also be there. It's not loaded, it must be short circuit condition. Okay. If it is a short circuited, then it is all right. Short circuit condition means iron loss will be zero, only copper loss will be there. Only copper loss will be there. So that to half load means 0.5 square into full load copper loss is 250. In that case, full load copper loss would have been 1000 watt. Correct? Now, what is a condition for maximum efficiency? We all know condition for maximum efficiency will be yes, iron loss by square root of iron loss by full load copper loss. Then it will be square root of iron loss 810, full load copper loss 1000. Okay. We cannot ignore iron loss in loaded condition, Mohan. How can we ignore? right? Loaded condition means both losses will be present. Okay, so this will give you 0.9. So 0.9, okay, that is the per unit load. So what is the actual load? 20 kVA. How much is 0.9 per unit of that? 18 kVA. Then 18 kVA is correct. Okay, right. So they should not use the word called loaded. They must use the word called short circuit. If you neglect iron loss under no load loaded condition, what is the purpose of calculating efficiency then? Right. They must use the word called short circuit. Right. Anyway, that is the answer for that. Yes. What is the primary function of a cumulative compound DC machine? Variable speed, low starting torque, constant speed, sudden heavy loads for short duration. Yes. Option D. We call them as intermittent loads. Intermittent loads. Sudden appearance of load, sudden disconnection of load. Intermittent loads. We will use, okay, a compound motor mainly for intermittent load applications. Okay. Intermittent load applications. Right. Next, the value of torque in electromagnetic energy conversion system depends on stator field strength, rotor field strength. Yes, direct torque equation. What is a general torque equation? Electromagnetic torque is directly proportional to minus F1 F2 sine lambda, where F1 is stator MMF, F2 is rotor MMF, lambda is angle between stator MMF and rotor MMF. Angle between stator MMF and rotor MMF. So it depends upon rotor field, stator field, and also the torque angle. We also call it as torque angle. Very important torque equation. Standard torque equation minus F1 F2 sine lambda. Torque is proportional to this. Minus sign indicates Lenz's law. According to that, stator field and rotor field will always try to align with each other. Therefore, they will attract with each other. So many discussions will be there. In regular class, we use it to discuss it. Okay. Yes. Next. In a DC machine, the effect of armature reaction under loaded condition is to, what is the effect of armature reaction? It will only distort the main flux without any reduction. It will only shift the magnetic neutral axis. It will strengthen main field flux due to cross magnetization, distort and weaken the main field flux. What is the correct answer? Yes. It will distort and also weaken the main field flux. Okay. This is also correct, but they use the word called only. Only is not a correct statement. Yes, it will shift the magnetic neutral axis in the direction of rotation for generator, opposite to the direction of rotation in motor. But they said only is not wrong. Correct. That is one of the effect. Okay. But not the only effect. But here it will distort the main field, distort and also weaken the main field flux. You know, what is the effect of armature reaction? Average effect of armature reaction is demagnetizing. Average effect of armature reaction is demagnetizing, right? That means the average flux per pole value will be reduced because of armature reaction. Okay, so the last option is the more suitable option. First option is also half of the option is correct, distorting the main field flux, but without any reduction is wrong. Actually, average flux per pole will be reduced. It's a demagnetizing effect. Okay. Right. Second statement is partially correct. If I remove that word only, then it is a correct statement only. MNA axis will be shifted in the direction of rotation for generator opposite to the direction of rotation for motor. Clear? Okay. Next, which type of motor is suitable for speed control using rotor rheostat control? Rotor rheostat control. DC shunt motor, slip ring induction motor, squirrel cage induction motor, synchronous motor. Rotor rheostat, slip ring machine. Okay. So in a slip ring induction machine, we can add extra resistance to the rotor circuit. When we add extra resistance in series with rotor, the operating speed of the machine will be reduced. Okay, slip ring induction motor is the suitable answer. In a squirrel cage induction motor, we can't add extra resistance to the rotor. Even in DC motor also, you cannot add anything to rotor. Only thing is that rotor is a closed circuit, right? Only to the brushes we can add some extra resistance. Okay. Directly to the rotor means only in slip ring machine we can add. A 4-pole DC machine has a 400 armature conductors and a wave winding. What is the number of parallel paths of the armature? Simple question. Wave winding, that means 2 parallel paths. If it is lap winding, number of parallel paths will be equal to number of poles, right? Then 4 is the answer. Clear? Right. In a DC machine, what is the main function of the pole shoes? To support the armature winding, to provide insulation between field coils and the yoke, to support the field winding, to spread the magnetic flux uniformly and reduce reluctance. Yes, this is the correct answer. See, in case of DC machine, pole shoes are having arc shaped surface, right? If this is the rotor, pole shoes will have arc shape something like this. Because of having these arc shaped pole shoes, field flux is distributed in a flat topped manner. If you take flux on y-axis and space angle on x-axis, field flux is distributed in a flat topped manner. Because of this flat topped nature, the average flux per pole will be increased. Compared to sinusoidal flux, the average flux per pole will be increased. So the flux is more uniformly distributed. Okay. Yes. And the area gap is uniform, right? From starting of the pole to the ending of the pole, area gap is uniform. That means reluctance is constant. Okay. So the last option will be the most suitable option. Also, if I ask you what is the advantage of arc-shaped pole shoe, average flux per pole will be increased, right? Next, basic questions. Faraday's law. According to Faraday's law of electromagnetic induction, which of the following statement best describes the magnitude of induced EMF in a circuit? It depends only on the shape of the conductor and not on the rate of change of flux linkages. It is inversely proportional to magnetic field strength and conductor length. It is inversely proportional to rate at which the flux is linkaging. It is directly proportional to time integral of flux linkages through the circuit. Yes, what is the correct answer? I think last option is correct, right? First statement is wrong. Why? Because the magnitude of induced EMF definitely depends upon the rate of change of flux linkages. Okay, and it is directly proportional also. d phi by dt. Okay, basic question. Next, in a shunt DC motor, if the field flux decreases due to field weakening, what happens to motor speed assuming constant armature voltage? Okay, see what is the speed equation first of all. Vt minus emergency service alert. All are you getting? Government was sending some messages yesterday. You have seen the news, right? Okay. Right. What is the speed equation? Vt minus Ia Ra by Ka into phi. Normally this IARA drop is very small, so we can neglect it. So speed will be dt by Ka phi. According to this statement, when flux is reduced or weak flux, speed will be increased. Okay, speed increases. What about torque value? Torque is Ka phi into Ia. Flux may be reduced, but current may increase. It depends upon the load. Torque increases or decreases, we can't describe. Torque value depends on load. For example, if it is a constant load torque application, even though flux reduces, current may increase. Okay, depends on the load. But speed will definitely increase because the flux is reduced. Okay, flux weakening method means flux reduces, speed increases. Okay, we are into the last leg. Which of the following most effectively minimizes sparking at the commutator during commutation on high load DC machine? Increasing the brush pressure, using a laminated armature core, reducing the number of armature conductor, employing interpoles with proper polarity. Yes, this is the correct answer. We already discussed resistance commutation, voltage commutation. In voltage commutation, we will use the help of interpoles to reduce the arcing and improve the commutation. Interpoles will neutralize reactance voltage so that commutation can be improved. So the last option is correct. Increasing the brush pressure will actually increase the sparking, right? The friction will more increase if you increase the brush pressure. Laminated armature core will reduce core loss but cannot reduce arcing. Okay, so the correct answer is the last option. Interpoles will help to neutralize reactance voltage so that arcing can be reduced. Next, a three-phase induction motor operating under unbalanced voltage conditions experiencing voltage unbalance factor of 3%. What is the approximate percentage increase in rotor current compared to balanced voltage condition? Okay, unbalanced voltage was given. 3% unbalance was there. What is the approximate percentage increase in rotor current compared to balanced condition? Okay, you just draw the equivalent circuit, right? Draw the equivalent circuit. If voltage is 3% unbalanced, what will happen to current? Yes, current will change by 3% or 60%, 15%, 18%. 4 options were given. What is the correct answer? Think about it. 3% unbalanced. Any options? Yes. See, normally what happens is unbalance means negative sequence harmonics will come into picture, right? When a voltage is unbalanced, negative sequence harmonics will come into picture. Okay, because of that negative sequence harmonics. Okay, see what is the torque equation? 3 by omega s into E2 square divided by R2 by S whole square plus X2 square into R2 by S. Okay, if the voltage is unbalanced by 3%, how much change in current can be expected? What is the formula for torque in terms of current? I2 square into R2 by S. Okay, yes. See, the point is when a voltage is unbalanced by 3%, unbalanced because of unbalanced voltages, normally what happens is negative sequence harmonics will come into picture. Because of the negative sequence harmonics, the resultant torque will be reduced. Okay, resultant torque will be reduced. If resultant torque reduces, what should happen? Let's say torque is reduced by some percentage. In order to increase the torque back to rated value, the current drawn by motor must increase. But the question is how much percentage the current has to increase. And there is a square relation you can see here. Am I right? So usually the current variation will be proportional to 2 times the square of the current variation will be proportional to 2 times square of the voltage balance. Voltage unbalance. Okay. There will be a theoretical proof for this, but I am not doing the derivation right now. It's a lengthy derivation. But from these two equations only we will derive it. If voltage is reduced by, or not reduced by, unbalanced by 3%, resolve that into 3 sequential circuits: positive sequence, negative sequence, and zero sequence. Of course, zero sequence is not effective in induction machine. Only we have to take the effect of positive and negative sequence. Finally, we will come to this derivation. Current will be proportional to 2 times the square of the voltage unbalance. What is the unbalance given? 3% and square it. It will become 9%. 9 into 2, overall 18% change in current can be observed. This is beyond the level of general AE level exams. Okay. But in negative, if you resolve that positive negative sequences, you will come to this particular conclusion. Okay. That much detailed derivation is not required, but you have to understand. Current will change by 2 times the square of the voltage unbalance. From sequential circuits, we can resolve this particular conclusion. Okay. So the answer would be around 18% usually. Okay. Right. Next. In a DC machine, compensating windings are connected in. We know intrapole winding and compensated winding both are connected in series with armature winding only, right? In series with armature winding. It's a straightforward question. Interpole winding and compensated winding both are connected in series with armature. Next. Maximum torque developed by a 3-phase induction motor dependent on rotor resistance. It is wrong. Sorry, independent. Independent is correct. We all know that maximum torque is independent of rotor resistance. What is the formula for maximum torque? Maximum torque is equal to 3 by omega s into E2 square by 2x2 Newton meter. It is independent of rotor resistance. This is correct. Dependent on voltage, directly proportional to rotor resistance. This is wrong. Okay. It is dependent on stator voltage only. Only is not correct. Inversely proportional to rotor reactance. This is also correct. Okay. Actually, A and D both are correct only. It is inversely proportional to rotor reactance. That is also correct. But if you wanted to choose only one option, this is correct option. The last option may change if stator impedance is also come into picture. This particular formula is valid when stator impedance is neglected. But if stator impedance is considered, the formula may slightly change. So most suitable answer will be the first option. Okay. Next. Fleming's left hand rule is primarily applied to find the direction of. Fleming's left hand rule, force. To find out the force acting on a current carrying conductor, we will use Fleming's left hand rule. To find out the induced EMF, we will use Fleming's right hand rule, right? Direct question. That's all, guys. Overall, 65 questions we discussed. Okay. You can see most of the questions are very much easy. Okay, just basic fundamentals only. Out of these 65 questions, I think 4 or 5 questions are slightly difficult, but remaining questions are almost 60 questions are very, very easy. You need to be strong with your fundamental basics and you need to cover the entire subject. You can't take any topic, choice. There are questions from minute topics also. Even separation of iron losses also question was there. Okay, questions are there on speed control method. Even starters, 3-point starter, 4-point starter question was there. Losses questions were there. OC test, SC test questions were there. Swinburne's test question was there. Okay, parallel operation of alternators questions were there. So we have to cover each and every topic, but exam is just 2 days, on 3rd or 2nd, I think. 3rd, right? Exam is on 3rd. Okay, so I wish you all the very best. I hope this session helped you to revise the subject, in a quick manner. So thank you so much and wishing you all the very best. Any questions you can ask me, I'll try to give you some replies. Okay, guys. So all the very best. I'm signing off the session. Okay, thank you.